Welcome back, everybody. This is our first lecture in JEE mains previous year questions for chapter electric charges and fields. And this is our starting lecture for class 12th. Before this, we have till now covered whole class 11, and today we'll be starting with class 12. And again, our whole playlist of previous videos is available on our channel. Again, name of channel is Point Basics, and there is dedicated playlist for these type of videos. And also, if you are a neet student, we have also have another dedicated playlist for previous years, so you can go to our channel and watch those videos in our playlist sections. There are two separate playlists for both neet and JEE. Again, if you find these videos useful, then press the like button, share them as much possible, and subscribe to our channel. Also, if you want to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your help and support, we will be able to keep on bringing you such quality content. So with this, let's start today's video. And here is question number 1 on your screen. So three charges plus q, small q, is we can say it is a test charge, and plus q are placed respectively at the distance d by 2 and d from the origin on the x-axis. If the net force experienced by plus q placed at x is equal to 0 is 0, then the value of small q is equal. So we have to find the value of q. So first of all, what we do, we make the arrangement that we will place all the charges according as described in the question. So suppose this is our coordinate axis, and here we have charges. So our plus q and q at distance d by t and d from the origin. So here it is. We have plus q at origin. So this is plus q at 0 0. Now we have a charge at d by 2, and this charge q at distance d by 2, I think. Now here it is not clearly mentioned, because here we have given three charges and only two distances are mentioned. You can see clearly that we have three charges and only two distance d by 2 and d are mentioned, and these are the distances for the second and third charge, because for first charge plus q we have already told that it is at x is equal to 0. So this small q is at d by 2 distance on x-axis, and plus q is at distance d on x-axis. So here we have q at d by 2 comma 0, and here we have again plus q at distance d comma 0. Now it is given that force on this charge particle is 0, so we have to find the value of small q. So as per given, that force, we know that force between two charge particle is given by k, q1 q2 by distance square or r square, where k is given by 1 by 4 epsilon naught. So force on q, which is at 0 0 we are talking about, it will be force from this charge, that will be k times capital Q small q divided by d by 2 square plus k times capital Q into capital Q, so capital Q square divided by distance between this charge and this charge is d, so d square, and as per given this is 0. So here we can easily cancel k, and while adjusting the equation we will get k q d square by 4 is equal to k q square by d square with negative sign. So k get cancelled, this q get cancelled, so a square get cancelled, and d square get cancelled. So we have q is equal to minus 4, this 4 will be here, and this will be in the denominator from this side. So minus q by 4. So this is the answer which we found out after calculation. And if we compare, here it is. So option A is the right answer as per our solution. Moving to next question. Consider is distributed. I think uh, charge is distributed. Okay, sorry, I read it wrong. Charge is distributed within a sphere of radius r with a volume charge density where capital A and small a are constant. If q is the total charge on this distribution, then the radius r is. So we have given charge distribution or charge density, and this is volume charge density. So we can solve this question easily. What we can do, we can consider a small sphere. So I'm here, I'm only showing here small cross section or spherical cross section. So consider this is a small sphere which we are considering, and now take a small element inside it. Here it is, I think. So suppose this is our small element at distance r and thickness dx. So suppose it is at distance x, we can say, and it has a thickness of dx. So we consider a small element inside this sphere of thickness dx. So we have a sphere of thickness dx at distance x from the center. Now we have to calculate the its volume. So dv will be its area. Area will be spherical area or surface area, that will be 4 pi x square into its thickness, we can say, and thickness we already know, that is dx. So its volume is area time thickness. Area is 4 pi x square into thickness dx. We have been given with charge density. So here we have given density is equal to a by r square e raised to power minus 2r by a. So this is charge density, this is volume of this small element. So we can find the small charge on this element by multiplying charge density into volume. So we can say dq is equal to rho r or rho x, we will be taking here, into dv, and these values will be given by dq will be, rho x will be a x square e minus 2x by a into 4 pi x square dx. This x square get cancelled, and we will be left with 4 pi a e raised to power minus 2x by a into dx. Now we will find the total charge, and total charge we can find out by integrating this value of dq. So q will be equal to integration of dq is equal to integration of 4 pi a e raised to power minus 2x by a to dx, and limits will be 0 to r, because we are considering that radius of this sphere is r, and it is also mentioned as r. So here 4 pi a is constant, 0 to r e raised to power minus 2x by a into dx, and its integration will give us 4 pi a as it is e raised to power minus 2x by a divided by minus 2 by a, limits goes to r and 0. Putting these values, 4 pi a as it is, this minus 2a by will reverse, so it will become minus a by 2 into, putting values of limits, minus 2r by a, negative sign, lower limit, so e raised to power 0, because when you put x is equal to 0, this will become e raised to power minus 0, and that will be, again, we can say easily e raised to power 0. We know e raised to power 0 is 1, and we have already have a negative sign here, so we will adjust the sign. So 4 pi a into 1 minus e raised to power minus 2r by a. That's our first part. Now, as per asked in question, we have to find radius of this charge distribution. So we have to find the radius. So to calculate the radius, let us, it is equal to q. Now from this we can, okay, I think we missed 2 here. This will cut at 2, so this is 2 pi a. So from here we will rearrange this equation to find the value of r. So q by 2 pi a is equal to 1 minus e raised to power minus 2r by a. This can be written as e raised to power minus 2r by a is equal to 1 minus q by 2 pi a. We can further arrange it by taking ln of both sides. So this will be minus 2r by a is equal to ln of 1 minus q by 2 pi a. Now we have to arrange this negative sign also. So 2ra will become 1 by ln of 1 minus q by 2 pi a, and now this will a here and 2 will come down in the denominator. So r will become a by 2 ln 1 minus q by 2 pi a. Let's check the answer. So here we have additional small a. I think we missed it somewhere. Yes, we missed it here. Here we had a also. So we have a here, a here, a here, a also, and here a also. And now let us copy this answer. And now paste it here. And now we can compare. So we have a by 2 ln 1 by 1 minus, here it is. So our option B matches with the answer. Now let's move to next question. So two identical conducting spheres A and B carry equal charge. They are separated by a distance much larger than their diameter. So effectively we have to neglect their diameter. And the force between them is F. A third identical conducting sphere C is uncharged. Sphere C is first touched to A and then to B and then removed. As a result, the force between A and B will be equal to. So here, as it is given that spheres are identical, and the third sphere C is also identical to A and B. So we can use shortcut here that assuming that their capacitance are equal, so their potentials will also be equal. So suppose these are two spheres. First is sphere A and second is sphere B. Now both are conducting and they have equal charges. So suppose this is also have plus q charge and this is also have plus q charge. So their initial force, so F initial is equal to K q square by, let their distance is d. So q square by d square. Now we have a third sphere, sphere C, and first, and this is neutral sphere, it does not have any charge. So if we connect sphere A and C, now as both of them are identical, so their charges will be distributed equally. So after connection, this q charge will distribute equally both on A and C. So this will become q by 2 and this will become q by t. Now we cut this connection. So after first readjustment, we have charges on A as q by 2 and charge on C as q by 2 and on charge on B is as plus q, and this is also plus q. Now sphere B and C are also touched, or we can say we made a connection between B and C. Now again both are identical, so their charges will be distributed such like that charges on both of spheres are equal. And keep in mind that will only happen if they are identical. If they are not identical, then we have to solve by using help of potential and capacitance. In that scenario, their potential will be equal and their charges will be distributed according to their capacitance. Because they are identical, though their capacitance are equal, that's why their charges are distributed equally. And in this case, when we make contact between B and C, so their total charge will be distributed such like that their charges on both of them are equal, or in short, charge on B will be given as q plus q by 2 divided by 2, and this will give us 3q by 2 or by 2 yani 3q by 4. So after contact between B and C, charges will become, and then after that we remove the contact, so charges will become 3q by 4 and 3q by 4. And now sphere C is removed, so we can remove this sphere. So this sphere is now removed, and now the force of attraction between attraction, or of the force between A and B will be equal to, or we can say force final is equal to K. Now we know charges, that will be 3q square by 8. Distance is as it is, so divided by d square. So what we will get? 3 by 8 K q square by d square, and this is equal to initial force. So F final is equal to 3 by 8 of F initial, and this is what we have to find, that force between A and B will be equal to, so that is equal to 3 by 8 of initial force, and that is 3 by 8 of initial force, that is F as per this question. So moving to next question. Shown in the figure are the 2-point charges plus q and minus q inside the cavity of a spherical shell. The charges are kept near the surface of a cavity on opposite sides of the center of the shell. If sigma 1 is the charge density on the inner surface and q1 is the net charge on it, and sigma 2 is the surface charge on the outer surface and net charge on it, then so we have to find out sigma 1, q1, sigma 2 and q2. Now we know that when there is any charge placed inside a cavity, so there is an induced charge on the inside surface or on the inner surface. So this plus q charge will induce negative q charge on this internal surface. and this negative q charge will induce positive or opposite q charge on the outer surface. Similarly, this negative q charge will induce positive q charge on the inner surface, and this positive q charge will induce negative q charge on the outer surface. So now on inner surface, total charge is minus q plus q, so 0. So in short, q1 is 0, total charge on the inner surface, and similarly, total charge on the outer surface is again 0. So from this we know that q1 and q2 is equal to 0. Now coming to the electric fields, or we can say surface charge densities. So surface charge density is given by net charge by surface area over A, and we know that on the inner surface net charge is 0. So sigma 1 is also 0, and similarly for the outer surface Q2 is 0, so sigma 2 will also be 0. So here we have option C, that will be the right answer. Now if we have been asked electric field, then that will be a different scenario, because electric field also depends on the distances. So that will be depend on the distribution of distances and the point on which it has been asked. From that point we will see the how that point is distributed across these two charges, then we will find the electric field. But you cannot say that surely it will be 0. So in next question, two charges each of equal to q kept at a distance minus a and plus a on x-axis, a particle of mass m and charge q node q by 2 is placed on the origin. If q node is very small, displaced with small displacement, the net force acting on the particle is proportional to. So this question is just like SHM that we previously have covered already. So in this question, what we will do, we will form SHM equation, and then using this SHM equation, we can find the required parameters or the net force acting that is acting on the particle. So let first of all draw a diagram for this. So suppose this is 0, 0, and we have first particle here, that is q, and it is at minus a comma 0, and second charge particle here, and it is at plus a comma 0, and at center we have placed at 0, 0 we have placed q by 2 charge particle. So now we can easily see that net force on this particle is 0, as this charge will be repelling it on the positive x-axis, and this charge will act as a repelling force on the negative x-axis. So net charge on the net force on this q by 2 charge will be 0. Now we have given it a small displacement, and that displacement is along y-axis. So initially all of these three are in a straight line, and now we have given a slight displacement. So these two q charges will stay as it is, and this q by 2 charge will go slightly downwards. So this will form a will form a triangle, and let us draw this triangle. So this is point A, B, C, and D. We know distance between A and C, that is A. This is known as given by A. This is also A, and this small displacement is small a. I think y. Sorry, displacement is y only. So now the here direction of forces, considering both all of these are repulsive forces. So due to, we can say, due to this positive q charge, force of repulsion on charge q by 2 here will be along this direction, and this force we can resolve in two components. First component will be like this and second component will be like this. Now similarly, due to this positive q charge, repulsive force on this q by 2 charge will be in this particular direction, and again this force can be resolved in two components. One will be the downward component and one will be the horizontal component. And here charge is q by 2. Let me write this. So now coming to the angles. Suppose we are going to take this angle as theta. So if this angle is theta, this angle will also be theta, and because both of these triangles are similar, so this will be theta also and this will be theta also. So this component and this component, these two components are equal and in opposite direction, so they will cancel each other and we will be left only with these two components, and they both will be added to give us the final value of the force or restoring force acting on this particle with charge q by 2. So let's find here this force and then we will take the components. So force will be equal to k q into q by 2, q into q by 2 divided by distance square, and distance is a, and I think we have given it name something o. Yes, we have given it o. So AO will be equal to, this is a right angle triangle, here this is a and this is y, so AO will be equal to under root square a square plus y square. So here's distance square, so it will be a square plus y square. So from this, force is equal to k q square divided by 2 a square plus y square. Now as already discussed that we will be left with only these components, and these components will be, if this is f, then this will be f cos theta and this will be f sin theta. So our net force will be 2f sin theta. So f net will be 2f sin theta, and now we have to find out the value of sin theta. So let's see this triangle. We know value of AO, that is this. We know the value of CO, that is y, and we know the value of AC, that is a. And in this triangle, sin theta will be CO divided by AC, and that will be y divided by a square plus y square. So we will multiply this value here or put value of f and sin theta to find the net force. So twice of k q square 2 a square plus y square multiply y a square plus y square. This 2 will get cancelled on both sides and we will be left with k q square a square plus y square raised to power 3 by 2. This is 1 power and this is half power, so 1 plus half, 3 by 2 into y. So this is the force, and as per given in the statement that y is smaller than a, so we will we will make use of this. As y is smaller than a, then we can easily ignore y by a, so here we will form y by a. That can be done easily. K q square y, we will take a square common from this, so a square 1 plus y square by a square raised to power 3 by 2, and as we know y is smaller than a, so y by a is neglected, so this will be left with a square raised to power 3 by 2, and that 2 will get cancelled and we will be left with divided by a cube. So using approximation we will be left with k square y by a cube. So we can say that force is proportional to y, and here it is, option A is the right answer. And we also know that in case of SHM, that force is proportional to displacement, so here we have answer 1. Now let's move to next question. So two balls of same mass and carrying equal charges are hung from a fixed support of length L at electrostatic equilibrium. Assuming that angles made by each thread is small, the separation x between the ball is proportional to. So first of all we will make a diagram for this. So let these are two threads. This is first thread and this is second thread. As there is electrostatic force acting, so these thread will be at some angle due to electrostatic repulsion, and we have two spheres here. This is first sphere and this is second sphere. Assuming these two are identical, now let's write down the forces. So the forces will be mg will be acting downward on each of them, so here mg is downward. Here we will have tension in the we can say this is support or thread, yes, so it is a thread, so there will be tension develop in this thread, and there is another force, that third one is due to repulsion between both of these two, so there will be a third force, that is repulsion. So this is mg, this is electrostatic force, and this is tension. Now tension can be resolved in two components, and this will be the first component and this will be the second component. Now if this angle is theta, so this will be also theta, and this will become t cos theta, and this will become t sin theta. Now at equilibrium all of these forces will balance with each other, or we can say t of cos theta is equal to mg and t of sin theta is equal to electrostatic repulsive force. Now if we divide both of these, then we can get sin theta by cos theta tangent theta, and tangent theta is equal to F electric by mg. Now as per question, uh, assuming that the angles made by each thread are small, so angles are small. For in case of small angle, tangent theta is equal to theta. Tangent theta is equal to theta for small angles. So using small angle approximation, theta will be F electric by mg, and now we have to find the value of theta for using this diagram. Now if we rearrange this, suppose this is point O, this is A, and this is B, and distance between A and B is x, because we have to use this distance to find electric repulsive force, so taking it is x. Now recreate this. This is O, this is A, and we create a middle point here, suppose C. So AC will be x by 2 and this angle is theta. Now using small angle approximation, we know that theta is equal to arc upon radius, and this radius is known as, we also know that length of this thread, that is L. So theta will be arc, that is x by 2 divided by L. So theta is equal to x by 2L. Or if you want to use the whole diagram, then we can draw like this, that this is O, this is A, and this is B, and this is X. This will be then 2 theta, and this will be L. From this, 2 theta will be x by L, and theta will be x by 2L. Putting these values here, theta is x by 2L, electric force will be K, assuming Q charges on both of these, Q square by distance square, that is x square, divided by mg. So x by 2L is equal to K Q square x square mg, and from this, x cube is equal to 2Q square into L by mg, or x is proportional to L raised to power 1 by 3. And that is, we have to find that the separation x between the ball is proportional to L raised to power 1 by 3. So option D will be the right answer. Now moving to next question. Two identical charge spheres suspended from common point, two masses. This is the same statement as per previous question. As a result, charges approach each other with velocity v, then the function of distance x between them. So now we have to find that how velocity is affected and how velocity is a function of distance between them. So from previous question, because both of them have same statement, from previous question we can use this relation. We will copy this, copy and paste. So from this we can use this this relation. I think we missed k here. Yes, we missed k here. So here will be k. So k will also be there. And we have to find the value of velocity, that how velocity is proportional to distance. So on this equation, we see that if we want to form a velocity here, then we have to use derivatives. We have to derivate this expression. So after derivating this, we will get velocity. But from this side, we also find a one variable whose derivative has to be taken, and that we can find from this part, that charge began to leak. So here in this question, charge is leaking, and so charge is reducing with time. So here in on this side, on the right hand side, we have q as a variable, and on left hand side we have x as a variable. So we can write only in the form of variables, that x cube is proportional to q square, because all other are constant, so we will be ignoring them. And from this we can say that q is proportional to x raised to power 3 by 2, and from this dq by dt is proportional to 3 x raised to power half into dx by dt, that is v. And now using this, if dq by dt is constant at a constant rate, so charge is reducing at a constant rate, we can say constant is proportional to 3x raised to power half into velocity. As this is constant, so we can say velocity is proportional to 1 by 3 x raised to power half, or velocity is proportional to x raised to power minus half. Now, using this expression, we can say that option D, option D is the right answer. So with this, we finish with this video here. This is our first video in this lecture series or in previous year question series for this chapter. Hopefully you will find it useful. And again, if you have any doubts or suggestions, then you can put them in the comment section. I always welcome them. And again, if you want to support us and if you like this video, then you can share these videos, like them and comment them. And if it is possible for you, then you can scan any of these QR codes and donate us with whatever amount you like. With your amount, we will be able to keep on making these videos and keep on bringing you this stuff. So with this, again, thanks for watching, and we will meet in next video.